Good morning everyone, this is sheet 9. First let's start with problem 1. Compute the electric field reflection coefficient for an air-steel interface at 30 MHz, 100 MHz and 1 GHz. Then compute the electric field transmission coefficient for an air-steel interface at this frequency. So we need to calculate the electric field reflection coefficient and electric field transmission coefficient at a variety of frequencies at 30 MHz, 100 MHz and 1 GHz. So first we need to get the value of the intrinsic impedance in order to get the value of electric field reflection coefficient, as reflection coefficient is equal to eta minus eta node over eta plus eta node. Eta node is the intrinsic impedance of air, which is equal to 120 pi, and the intrinsic impedance eta is the intrinsic impedance of the material, in this problem the material is air steel. So let's first get the value of intrinsic impedance of the material, which is equal to square root omega mu naught mu r over sigma cu. Sigma is the conductivity of the material and sigma cu is the conductivity of copper. So let's first convert from polar to Cartesian. Here is 1 angle 45. We can convert it to Cartesian in this formula, r cosine theta. Theta is the angle here, which is equal to 45. Sine, and if we need to get the value of y. So r sine theta, r is the value which is equal to 1. Theta is the angle which is equal to 45. So x plus jy equal root 2 over 2 plus j root 2 over 2. We plugged it in here instead of phase. We convert it into Cartesian in order to be able to calculate it on calculator. So frequency, it is given, a variety of frequencies are given. So you need to plug it one by one. First at 30 MHz. So we calculated here 30 MHz. Mu naught, you can get its value on calculator, which is equal to 4 pi 10 power negative 7. Mu r of the steel is equal to 1000. Sigma of the steel is equal to 0.1. And copper, the conductivity of copper is equal to 5.9 times 10 power 7. So at 30 MHz, we get the intrinsic impedance is equal to 0.1429 plus j 0.1429. Now we need to get it at 100 MHz. So all we need to do is changing the variable of frequency here by 100 MHz. Finally, we need to get the value of the intrinsic impedance at 1 GHz. So we substitute f by 1 times 10 power 9, and we get the value of intrinsic impedance is equal to 0.825 plus j 0.825. Now we still didn't get the value of electric field reflection coefficient, but we get the values of intrinsic impedance, which is a component relative to reflection coefficient. As previously we know, reflection coefficient is equal to eta minus eta node over eta plus eta node. We get the values of all etas in different frequencies from these equations. Then we need to substitute it one by one at each frequency to get the value of reflection coefficient. Eta node is intrinsic impedance of air, which is equal to 120 pi or 377 ohm. So we get at 30 MHz, we get reflection coefficient at 100 MHz, and finally at 1 GHz is equal to this value. Second, we need to get the value of transmission coefficient. We need to get the value of electric field transmission coefficient. It's simple, as its rule is equal to 2 eta over eta plus 377, which is equal eta naught. Eta, we already get it from above. These values represent eta at different frequencies. So if we need to get the transmission coefficient at 30 MHz, we need to substitute by eta that we get it from the above at 30 MHz. So in which it is equal to 0.1429 plus j 0.1429. Then substitute in this equation, we get the value of transmission coefficient. The same criteria. If we need to get the value of transmission coefficient at 100 MHz, we change the eta here by the one we get it from the above, which is equal to, in this case at 100 MHz, it will be equal to 0.2609 plus j 0.2609, and we substitute in this formula, and finally we can get our value of electric field transmission coefficient. The same way as for 1 GHz, we can get this value easily. Let's check second problem. Compute the reflection loss and absorption loss for a 20 mm steel barrier at 10 kHz, 100 kHz, and 1 MHz for a near field electric source that is a distance of 5 cm from the shield. So basically we need to get the value of reflection loss and absorption loss for a steel of thickness 20 mm at different frequencies, which is 10 kHz, 100 kHz, 1 MHz, and it is placed at a distance of 5 cm from the shield. So let's check first the reflection loss. Reflection loss is given as this formula, which is equal to 322 plus 10 log 10 sigma r, which is the conductivity of the material, mu r permeativity, f is the frequency, r is the distance. So at 10 kHz we need to get the value of reflection loss. So from the above we knew that sigma, or conductivity of steel, is equal to 0.1 and mu r is equal to 1000. So by substituting by its values, and the frequency is equal to 10 kHz, so we convert it here to hertz, 10 by 10 power 3, and the r is equal to 5 cm. We substitute it by 5 by 10 power negative 2 in order to convert it to meter. Then easily we can get the value of reflection loss, which is equal to 188.02 dB at 10 kHz. Second, we need to get the value of the reflection loss at 100 kHz. So its value, all we need to substitute is the frequency here. Instead of putting 10 by 10 power 3, we put 100 times 10 power 3, and we get the value of the reflection loss at 100 kHz, as well as at 1 MHz the reflection loss is equal to 128.02 dB. Now we need to get the absorption loss. So absorption loss is equal to 3.338 T. T represents the thickness, and multiplying by square root f mu r sigma r. T in inches, so we need to convert, since in the problem it is given that the thickness is given in mile, so we need to convert mile to inch in order to substitute in this formula. So multiplying 20 mil by 0.001 inch, we can get the value of the thickness in inch. So 3.338 times the thickness in inch, which is equal to 0.02, multiplying square root frequency at 10 kilohertz, 10 by 10 power 3, times mu r of the steel is equal to 1000, and multiplying by conductivity of the material, in which in this case is the steel, is equal to 0.1. So by multiplying all these on the calculator, you can get the value of absorption loss at 10 kilohertz, which is equal to 66.76 dB. The same thing at 100 kilohertz and 1 megahertz. You substitute the frequency here and get the value of absorption loss. Third question: a shield that contains 10 identical holes in a linear array is required to have 30 dB of shielding effectiveness at 100 MHz. What is the maximum linear dimension of one hole? So we need to get the value of L, and given the number of array is equal to 10, and the shield effectiveness is given as 30 dB, and given the frequency is equal to 100 MHz. So what is the length? So the rule of shield effectiveness is equal to 20 log 10, 150 over frequency in megahertz, multiplying by length in meters, multiplying by square root the number of arrays or number of holes. So by substituting the shield effectiveness here equal to 30, and F is given in megahertz, so we put it here. We need to get the value of the length, and the number N is given by 10. So all these equations have one unknown, so we can solve it as follows. In order to cancel the log, we get 10 power 30 over 20 equal to these values, and from here we can get the value of the length, which is equal to 0.015 meter, and we can convert it if it need to convert it to centimeter, and it will equal 1.5 centimeter. Finally, a shield has a 5 by 12 array of 1/8 inch diameter cooling holes. What will be the shielding effectiveness at 25 MHz? So the frequency is equal to 250 MHz. It's given in mega. The number of arrays is equal to 12. The length is given in 1/8 inch. So we need to calculate the value of shielding effectiveness, which is S. But first, let's convert the inch into meters. We multiply it by 0.0254 in order to get the value in meter. So the shielding effectiveness is equal to 20 log 150 over frequency in megahertz, multiplying by length in meter, multiplying by square root number of holes or arrays. So all is given. All you need to do is to calculate the shield effectiveness. So frequency is equal to 250 megahertz. L, we convert it into meter, which is equal to 3.175 times 10 power negative 3, and N is a number which is equal to 12. By calculating it, we get the value of 34.7 dB. Thank you.